Good afternoon, everyone. I'm John Anderson, and welcome to the latest Skarn webinar. And today we're going to be looking at something a bit different for Skarn. We're going to be looking at recycling. First of all, a little bit of housekeeping. Basically, questions. Looking forward to quite a few of those. You can put them at any time using the Q&A function, and we'll look at those at the end and see what you come up with. We also do have reactions, but obviously we've set that up so you can only send us happy smiley faces, and we won't be doing any polling. If you are, though, interested in hydrogen-fueled anode furnaces, you should check out our little article that we wrote in the Skarn Decarbonisation Quarterly. And while we're on the subject of hydrogen, please check out my latest article about hydrogen supply on the new Skarn Edge. Well, enough of that. Recycling. It's, in my opinion, quite a big topic. I've got 20 minutes. So I think we've really just got to look at this as what we could do. Welcome to the start of our journey together through recycling. So what am I going to look at today? Well, first of all, I'm going to start with really where does recycling sit in what we call circularity, the circular economy. Then we're going to look more at metals production and recycling and that age-old question, primary versus secondary, followed by very much an in-depth look at zinc industry and lead industry, my two favourite metals. So let's jump right in there. Okay, recycling circularity. It amazes me the number of times you actually hear the phrase, well, circular economy, well, that's all about recycling, isn't it? I even read something recently that basically said, the world recycling ratio is, the world circularity ratio is going down. And that's all because of recycling. Then someone actually pointed out that, in fact, the recycling ratios around the world are probably going up. And it's actually the huge amount of waste that is just going up and up and up that's causing the drop down in circularity. And in fact, as you see from this diagram that has come from the European Parliament, really recycling isn't circularity. It's a part of the circular economy. And typically we end up with 3 R's: reuse, repair, and then finally recycle, to get those units, be they metal or non-metal or even glass, as in this example, back into the value chain. But then it's not just about 3 R's. There's also lots of other R's that have been brought into this circularity argument: reduce, redesign, recover, refurbish, repurpose, rethink, refuse. And I hope you're all there now thinking of lots of other words that begin with R that you can put in that list as well. But if you think, these are actually opportunities in each one of those areas, not only to help develop the circular economy, but also to help really recycling. You could say the tail end Charlie of all of this, the final one, once we've used something, repaired it, whatever, and get the values back in the value chain. And if you think, you look at this and say, well, if you actually design, or should I say redesign something that actually helps in its recycling, once we've gone through all these R's, then again, that's helping recycling as well as the circular economy. So we now rather see where recycling sits in the circular economy, or what exactly it's all about. So what does this actually mean in terms of metals production? Well, basically, let's just have a look at things. So we go on about primary and secondary industries, and everyone's, you hear these phrases. Primary base metal smelters, they're designed to process sulfide concentrates. And secondary smelters are designed to process recycled feed. I mean, it's a simple remelting exercise. I mean, everyone knows what copper scrap is. It's bits of wire and tubes, and you just remelt them. Same with aluminium. It's all about cans. You just remelt them and it's done. Well, clearly, it's just not the case. I mean, let's have a look in terms of purely the primary industry. What are the opportunities there? Well, primary smelters do have an opportunity to feed secondary or recycled materials. And normally it's based around the sort of heat and mass balance options for the plant we're talking about. Now, in terms of heat, there's often areas around a particular smelter where there's excess heat. That heat can actually be used to melt or start metallurgical processing of a secondary or recycled feed within the primary operation. The other one, in terms of mass, well, I mean, often, I mean, if you think plants are always built with a nameplate capacity, but how many times do things not live up to expectations? And there's capacity areas that we could optimize, get full capacity by breeding secondary materials, recycled materials there. I mean, the classic case has to be smelters that, for example, have a tank house on the end. Often tank houses are sized bigger than the rest of the unit. I mean, you look at, say, Japanese zinc smelters, for example, their tank houses are usually very big due to the fact that it allows the plant to operate in day mode, night mode, holiday mode, weekend mode, so they can optimize the tariffs. But inherently, that gives you a potential capacity that you can feed. So, for example, you could easily set up a separate line processing secondary materials within a primary smelter. So that secondary line, so for zinc, makes zinc sulfate that you can then electrowin, or perhaps makes lead or copper anodes that you could then turn into refined copper or lead at the end of the day. I mean, it's very interesting. There's a lot of examples of that. You look at, say, someone like Guishi in China, copper smelter with a secondary line. You look at, some of the Japanese smelters on Ahama, for example, where it's got a secondary e-scrap processing line running on the end, running alongside the primary. I mean, just today I was looking, and it's interesting that Aluminium Dunkirk have just brought online what they're calling Furnace 8, which is basically a scrap recycling furnace within the primary smelter itself. So again, it's an opportunity, but it's not radical. People are doing this, so it should be utilized. So, we've seen a couple of misconceptions, or the opportunities. The reality is that at the end of the day, you look at the demand that's being fueled by decarbonisation around the world. And what do you see is huge demand for metals like copper, precious metals, things like this. And so to really get enough metal units, we're going to have to recycle using both primary and secondary smelters. They're going to, I guess the word is coexist. But within both of those niches, primary and secondary, there's going to be opportunities for both to increase the amount of recycled material, increase the amount of metal units, really buy into that circular economy. So, okay, that's really I could say the concept of it all at a sort of high level. Let's just do a bit of more of a deep dive into a couple of the metals. Firstly, zinc. On the left here, you've got quite a simple diagram that explains the zinc value chain from really virgin units in terms of the mine, right the way through to a sort of finished product and the recycling options around it. I mean, zinc is obviously an interesting one because a lot of it is used very much in protection, in galvanic protection to protect steel. So a lot of zinc units are lost. So you will always need to put virgin units into the value chain. But again, we need to optimize the amount of recycling that is done so that we're just literally not throwing zinc units away. It's very interesting. Zinc really sits into two areas. We have really what are metallic residues and also non-metallic. Metallic, we're really talking the residues coming out of galvanizers. Things like top dross, bottom dross, and also what they call galvanizers ashes. Now, that's quite an interesting one in its own right, because obviously once you ball mill something like galvanizers ashes, it separates into a metallic and non-metallic phase. The non-metallics, which are zinc oxide, can then be fed back to the primary smelter. So again, you have a recycle within the recycle. But critically, metallic zinc scrap, well, basically the main dominant process for zinc processing is the roast leach electrowin process, known typically as RLE. Now, that actually can't tolerate large amounts of metals. I can hear quite a few people saying, well, it can, because you can add some at the melting and casting area. Yeah, but at that point, you're right down the end of the process. You have to be absolutely sure of what you're putting in. If you put something in that has any sort of contaminant, you're going to put your final product off spec. So really, we need a new alternative technology other than the roast leach electrowin to process this metallic dross. And basically, a whole industry has popped up with this niche technology, typically based around things like the French process, which takes these drosses and produces high-grade zinc oxide, high-grade zinc chemicals to feed into the end user. The other side of the equation here is the non-metallic, and really we're talking EAF dust, basically the dust that's produced by electric arc furnaces. Now, interestingly, the big issue with this stuff is it's obviously coming from a steelmaking process, and it's only got about 20% zinc in. There's a lot of iron with it, and roast leach electrowin plants cannot tolerate iron. So we have to be able to upgrade it and take it really from about 20% zinc to about 60 before it could actually go into these RLE plants and remove as much of the iron essentially as you can. So what has happened is a whole industry has grown up that basically takes the dust and upgrades it and feeds it then into the primary industry. In fact, as well as just upgrading the dust and removing iron, they're also doing what is called a washing exercise, where basically you're removing halogens, typically fluorine and chlorine, to allow, again, significant tonnages to be taken by a primary smelter. So really, it's a really interesting example of where one absolutely needs the other. They have to coexist. Interestingly, EAFs, well, if you think that's what the steel industry is heading towards, you look at a lot of the decarbonisation strategies, and they're all based about movement away from the blast furnace route to the EAF route. So inherently, aren't we therefore going to produce lots more dust, which is great because there's potentially more zinc coming through this. As with a lot of things, there's always a but. There is a big but here, and that is that this dust is only any good within the zinc value chain if the electric arc furnace is processing galvanized scrap. Galvanized scrap is essentially scrap steel coated in protective layer of zinc. When it goes in the EAF, the zinc volatilizes off and ends up in the dust, hence why it's in the EAF dust. So if all these new furnaces come along, don't actually treat galvanized scrap, we could end up with a lot of dust that really isn't that helpful for the zinc industry. So there may be, yes, there's opportunity there, but a bit of a caveat. The other real caveat with this is that essentially this whole industry that has grown up to pre-process EAF dust very much uses the Volts kiln. Now, the problem with that is that it uses normally coal or coke as its fuel. And inherently in that, it's going to release GHG emissions, CO2, when the coal and coke reacts. So we have a bit of an issue. We have a process that provides, as I say here, an easy technical and environmental massive solution to EAF dust, which is very much a hazardous waste. But if you focus on the one parameter, GHG emissions, what are you going to do? Close that whole loop off? And what do you do with the dust? Now, I guess what I have to do here is what's called a shout out. And that's very much to the International Zinc Association, the IZA, who very much picked up the baton here and come up with working with the steel industry associations, very much come up with a very pragmatic solution here that essentially proportions the emission numbers between zinc, the zinc industry and the steel industry, so that if you just focus on CO2, you are not condemning this EAF route. So at the end of the day, we have a very good solution, which is good when you see some of the academic papers out there, especially one I happened to see on copper processing of e-scrap, which seemed, when you focused on certain parameters, seemed to really indicate this was not an idea. And you think, but e-scrap is a major, major issue. We've got to be able to get the copper and notably the silver and gold back. So it's really great to see that we've managed to get a pragmatic solution in place here and keep this recycling going. And, again, offering opportunities as potentially more dust comes online. So that's zinc. Let's have now a look at lead. Lead. Go. When I first started in the metals industry, lead was, its days were numbered. It was a dead man walking. We were going to have lead-free galvanizing. We were going to have lead-free solder. Lead in air and blood was a massive issue. If you think in the UK, for example, we moved away from leaded fuel to unleaded fuel because of all these issues. If you look in that scenario, if lead demand is going down and down and down and down, then basically secondary lead smelters, those are the smelters that literally, as the diagram says, here, just take batteries and break them to generate lead, could easily take the whole demand. So what would that be? The end of primary lead. So we look at the simplified diagram of lead and the whole primary side would disappear. Really? Is that a reality? Well, it's quite interesting. I mean, lead acid battery demand still seems to be going along quite strongly, and doesn't it? You know, there's still a need for lead in various things. Interestingly, something perhaps overlooked is that you look at that diagram and you see that lead concentrates are actually a very key revenue stream for miners. If you think lead geology and zinc geology, in a zinc mine, you're going to get lead and zinc together. So, you know, miners want to optimize their revenue, and what they're going to do, separate the zinc into a zinc concentrate, lead concentrate. If you don't have a market for lead concentrates, what are they going to do with it? Is that really reality? The other thing is lead concentrates typically contain precious metals, notably silver. And so it's a key way of getting silver units, virgin silver units, into the value chain. So, you know, this lost end of the primary lead to becoming one, really, it's just not going to happen. So really what we'd probably like to see is they're both going to continue. Could we say an uneasy coexistence, because they're both going to fight for these scrap batteries? But, you know, there are scenarios where both will exist because of their positioning in relation to markets, in relation to battery supply. And if you think at the end of the day, that's extremely good for recycling, because we're ensuring that lead acid batteries, but by their name, not only have got lead in, they're plastic coating, so we managed to keep that, and also they've got acid in. So we're managing to process this sort of material, and hopefully this sort of pressure will mean that any backstreet, if we can call them that, recycling is removed, and we end up with correct recycling routes. And inherently then, well, what does that mean? It's got to be really great for environmental protection. So, as I said, I had 20 minutes. I look at my clock and I see I'm just about up. So, I guess in the words of Winston Churchill, well, just about, you know, this isn't the end. In reality, it's just the end of the beginning, really, for our journey through recycling. Obviously, in this example, we have looked at lead and zinc. There are lots of other things we could do. And as I say, one of the things I did forget to mention at the beginning is obviously this is going to be recorded, this webinar. It will go up on our website. Because you've actually listened to the webinar today, you'll be able to access it again in your own time, but also all our other options. So go up there and have a look what's up there. But this could be considered the first of perhaps a number of webinars. Let's see your Q&As. Let's, you know, put some ideas up for us there that you might want to see as we look at the recycling of other metals. As I say, my interest in this has been long. And yes, I picked two because, yes, I have a soft spot for lead and zinc, but I could have easily talked about e-scrap, the black mass of lithium, you know, you name it. So I will stop there and go to my colleague, Derek, and say, Derek, what questions have people been putting in for me?
Well, thanks, John. That was absolutely fascinating. I've learned so much in that short little talk. And as you say, so we've just started a series. Really, this is the first of what we hope is a continuing series on recycling. So if we don't get to answer your question this time or on a particular topic, don't panic. You can always just send us it. We can respond either via email or we can answer it in a future session. There's got a couple of questions to start the ball rolling, John. Number one is, could you give an example of how embracing the R's through the value chain could help a circular economy?
I think I'd probably look at a very quite specific example there. You look at sort of IT stuff, mobile phones, things like this. You know, we seem to have very short timescales. Well, younger people seem to have very short timescales, and we literally get a phone, throw it away. I think we really need to redesign and relook at this and say we really need to be able to repair them, be able to reuse them. So if you don't want your whatever version 10, you've moved on to version 20, someone else might want that 10, so there's a way of doing it. But also, importantly, you know, these things, yes, they don't last forever. Computers don't last forever. We need to be able to recycle it. So we need to be able to redesign things so that, I mean, and you know, recycling isn't just shredding it up and sticking it in a smelter. Recycling could be, especially in e-scrap, something like the ITAD industry, big in America, where literally they are repurposing. I must stop using these R's. The electronics for other things. But you know, that requires good design up front, good purposing up front, so you can literally, you know, commonality things. I appreciate you've got different companies involved, but I'm sure, you know, tight standards to ensure that when you get, you know, one of the recycling companies gets a, you know, be it a phone or even white goods or anything, they can just break it up easily in a quite easy way and recover. Not just, oh, well, we can only get aluminium out of this, or we can get everything out of it, not only metals, but non-metals as well. Because obviously plastics in the ocean, you know, it's a big issue as well.
Yeah, thanks, John. One of the questions that's come in is associated with the risks to, you know, for mining and metals from recycling. One of our questions is, what risks do you see for mining and metals from recycling?
I think the thing, I think there is always this belief, isn't there, that recycling will just completely take over. We don't need virgin metals. You know, there is no need for mining. If you look at the zinc example, you can't get it. You have to have zinc mining. You cannot. You know, there just isn't enough recycling, and because it's a metal that is lost all the time, it can't produce. You look then at, say, aluminium, say at copper, and you look at the sort of demand numbers that are coming in, and again, there just isn't the material there because, you know, my flippant example earlier, there's time lags on this. So, you know, how quickly can you get this material back in? I mean, you look at lithium, we're already trying to figure out how we're going to recycle lithium batteries when we haven't really got into lithium batteries yet. So we will always need mining to run alongside secondary smelting. I think the problem is that in the past we have gone down this very entrenched route. Primaries do primaries, secondaries do secondaries, never the twain will meet. Yet they have to work side by side. Can I say that? That sort of environment. So I think, yes, you could look at what is the risk, and you know, you look at any cost curve, any emission curve, any revenue curve, and you know, the ones at the wrong end, really, should they be there? But you know, and you also look at, you know, how things move on. You know, you look at mines and you say, okay, you're primary mining this, but you also have residues that perhaps you could be urban mining at the same time. So you could end up with a mine actually, as it's becoming exhausted, moving over to become a urban mine, where they're reprocessing dumps or something like this. And again, I mean, I wrote an article, way back for Skarn, looking at processing of tips. And my argument there was, if you've got a copper mine, don't mine the tailings pond for copper. Mine it for what else might be in there that they never thought of recovering in the previous. So, you know, your EOMs, your galliums, telluriums, whatever EOMs you've got for electronics, there could be serious quantities in there that no one ever thought about. So again, perhaps it's a very positive view, but I would see the risk changing and perhaps, you know, rethinking. And, you know, it's interesting, a number of the big mining companies are actually saying that now. You know, we are reprocessing our dumps, but not recovering what the mine was actually there for.
Yeah, I really like that idea of like trying to get a balance between the using the virgin metals and recycled products as well. And one of our questions like sort of alludes to that a little bit. One of our viewers has said they're interested in copper, but they're wondering if there's almost like products which we can't use recycled materials? Is there any kind of massive industry you can think of that's really kind of recycling proof, or is recycling something we could be considering for almost every product that involves metals?
Yeah, I mean, it's an interesting one, isn't it? Because you look at, I mean, the one that leaps to mind is aluminium. And, the aluminium industry is driven by aluminium alloys, and the alloys are similar but completely different. They have small quantities, this, that, and the other to make them do it. And there is always this argument, oh, you need virgin aluminium to do this, that, to make this sort of alloys. And I guess what I would say is it's like a fear factor. Who's going to make an aeroplane out of something where you've always been told it has to be primary metal? And now I'm going to make it out of recycle. But I mean, you look, the steel industry has been here and is now making more and more stuff. I would say recycle proof. I don't really like the word, to be honest. I think, you've got to look at the end of the day, what is going to drive demand? And that's customer demand. So if that you look, and yes, I appreciate that it's all fickle, but at the moment, people are saying I want to buy a car and I want, to see its green credentials. So again, this is where, primary metal, but with a recycled content, is probably the way we're going to be going forward. Is there anything? I mean, it's interesting. I was actually thinking, something like gold, silver, but then you look at something like the efforts being done by the Royal Mint in the UK, where literally they're taking PCBs in to actually get the gold out of it. So, and they're actually marketing a whole range of recycled gold jewelry and gold products from this. So, even there where you'd normally think, oh no, you've got to have a virgin metal. I guess it's all about risk. And, can you actually, someone has to sign off at the end of the day and say, yeah, we're happy that our latest whatever is going to be okay with this. The reason we use virgin metal is because we understand the properties, sort of in terms of bend or whatever, and we know what it's going to do. We potentially are into new territory here, but then it's about testing and seeing what comes at the end of the day.
Okay, thanks. I appreciate that. Can I just ask you a question that's kind of related more to your presentation? You were talking about the Veldskin. Do you see any other technologies replacing the Veldskin for the processing of say EAF dust?
It's a difficult one because the Volts kiln is so well entrenched in that, and it's such a simple, relatively simple technique. There's been the companies that are really big in this have worked hard on optimizing it. But at the end of the day, there's always a holy grail on this. EAF dust in its raw form is mainly iron. So why do we recover the zinc yet the iron is still a waste? How are we going to be able to get those iron units back into the iron value chain? I mean, there was the use of the technologies based around the rotary hearth furnace, which essentially generated what's called a DRI, direct reduced iron product, which is a highly metallized product that was starting to become acceptable to the steel industries. And you started to see a few years ago now, a lot of the new Chinese, Japanese plants putting in fast met, RHF-based plants. But it was really to deal with a problem of the very low levels of zinc causing problems in blast furnaces. And inherently, they were recovering their iron units, and they just happened to make a very nice zinc product as well. So that may get it, but it's a cost revenue thing. Volts kiln is so simple to operate. I mean, I have to put my hand up and go, I'm a big proponent of top submerged lance technology. I love it. I think it gets to a much higher temperature. It gets to what we call smelting temperatures. And therefore, you really get everything you physically can out of that dust or whatever your feed is. So your EOMs are going to go into your dust. And I mean, the Chinese were always very good at being able to leach basically indium out of these products. So you look and go, I like that. Oh, yeah, I appreciate the capex is huge and there's big footprints and everything, but I always like it. And I would just leave you with the phrase hydrogen fueled TSL, completely decarbonized processing route.
Well, Time's winged chariot has caught us up again, once again. Is that the final thought? Is there a final thought you want to leave us with before we say goodbye?
I guess I think I'd just reiterate what I was saying at the beginning. This is very much Skarn's, can we call it foot, just tip into the water here. This is the beginning of a journey onto recycling. Yeah, we covered a few things today in a very short session. There's lots of other things that we can, look into. So, let's see your questions, and yeah, please come and talk to us about it. What can we do to help? We have quite a lot of already knowledge that we built up on this.
Thanks very much, and thanks everybody for joining us today. If, as John says, if you've got any other questions, please just write to us, and we're happy to answer them offline. But thanks for attending. It's goodbye from me.
Goodbye from me. Cheers now.